disk management. Okay, disk management. What is a disk management? Normally, whenever in our Windows, we have a hard disk, right? We have a hard disk in our Windows. How it is? This is the hard disk. You have different partitions, MBR, GPT, whatever it is, we have a partitions are there. In Windows, first of all, I am trying to tell in a Windows because we know the Windows 10, so that's why I am telling Windows. In Windows, we have a disk 1. Normally, starting disk is disk 0. Next disk is disk 1, disk 2, like this, hard disk are there. And we have a partition. Each partition has a drive letter to access. C drive, D drive, E drive, F drive, like this. We have drive letters to access partition. So usually C drive having operating system, others having other regular data, right? So this is a disk 0, partition 1, partition 2, partition 0, like that it is there. But in Windows, we access the hard disk. We access the hard disk, C drive, D drive, E drive directly. Drives wise, we are accessing in a GUI mode. In Linux, it is different. In a Linux, it is the naming is different, accessing is different. So in a Linux, the naming is like this. Linux, the naming is like this. Look at disk 0 instead of disk 0. It is like a dev. Under dev, dev means drive contains hard disk, hardware files, SDA, okay, and the partition names. You have a partitions like this. These partition names are like this. SDA1. Okay. So better change a little smaller. Okay. It is very small. Little big. 14 is better. Yeah. Like this. /dev/ SDA2 /dev/ SDA3 means SDA first partition is SDA1, SDA2, SDA3. No drive letters. You have to mount, then only we can access. For example, I have a partition SDA4. For example, I want to store the data. I want to store the data in this particular partition. For example, this is a 10 GB partition. It is a 10 GB partition. So I have to create a folder somewhere in my system, anywhere, somewhere in my system, I create a folder. So for example, I am creating a folder for 1 to 2. Okay, I created a folder or a directory. Okay, mount this folder here to here. So I put a color, little color. So we are mounting, means linking. We are exactly say linking. So you put a data in this folder. Data stores in this inside this drive. Data stores inside this drive. What are the data you store in this folder? That stores in this drive only. It is a mounting files. Okay, so same thing. Little few more points should be covered here. So that is, if you have a multiple disk in Windows, disk 0, disk 1, disk 2 kind of stuff is there. But in a Linux, it's not like that. In a Linux, the names are SDA SDB, SDC, like that. Okay, this is the another hard disk. So names are like /dev/SDC. Okay, names are, it will be there. But again, I'm writing here. Okay, actually I want to write here. Look at SDA. Out of this /dev/SDA, meaning is D represent disk. It is a constant. It is a constant. A represent first one. B represent second one, second disk. First disk, second disk. A1 represent, okay, A1 represent disk partition 1. Disk partition 1. Disk partition 1. In first disk, disk 1, partition 1. A2, disk 2, sorry, disk 1, partition 2. For example, B1, disk 1, sorry, disk 2, partition 2, like this. So D, the center one D represent disk. The center one D represent disk. What I'm going to do is I'll change the color of the disk. I'll put a disk color is like this. Okay, disk. Just for understanding, color disk. So A's color is I'll put a yellow color. Okay, so this is yellow color like this. Okay, A2 yellow color. Numbers are okay, no problem. So we can understand numbers. Okay, the S now finally yes. So blue color I will put it yes. Now look at here. S represent SCSI type of disk. S represent SCSI type of disk. H represent hard disk. V represent virtual disk. Virtual hard disk or a virtual disk. Virtual hard disk or a virtual disk. So that is the position. So like this. Okay. So this is can be like this. Okay. /dev/HDA /dev/VDA like this. The H represent hard disk, V represent virtual hard disk, D represent it is a disk drive, hard disk drive. A represent first, B represent second. Okay, so by this maybe you can understand or not, so don't worry. S represent SCSI disk. So I am using SCSI disk. It is showing yes. If you are using physical machine, directly install OS in physical machine, it will show HDA, HDB, HDC like that. If you are having a Linux machine, inside a Linux, you create a virtual machine. That disk format inside a virtual machine is VDA. Okay, so that is little confusion now, but fixed it. SDA, SDB, SDC. 1, disk 0, disk 1, disk 2 in Windows. In partition names are SDA1, SDA2, SDA3, SDA4. Okay. If in case you use your physical machine, you take a desktop, install a Linux operating system directly in the desktop. Then hard disk name, normal hard disk, IDE type of hard disk. SDD, it means it is IDE, IDE, SATA, hard disk. Any name. So because of different names are there, again are told some different kind of stuff people will tell. So don't go with like this. Yeah. Hard disk is ID hard disk, SATA PATA hard disk, or anything. Okay, it is IDE, PATA type or SATA type of whatever the disk it is. Okay. Okay. Why color is not changing? I don't understand. It irritates me more. Okay, right. That's it. Its colors are not changing. IDE, PATA. Now wait, why it is not in a bold color? Okay, no problem. HDD means if you are installing Linux in a machine, the hard disk is SATA hard disk or PATA hard disk, then H. If the hard disk is SCSI hard disk, SCSI or SAS serial SCSI disk, then it is shows as a SSI. You have a Linux machine. Inside a Linux machine, you are using QEMU kind of format. Okay, so that is a QEMU or a KVM Linux based virtualization platforms. On that one, you create a virtual machine. A Linux virtual machine is created. Inside a Linux virtual machine, you check the hard disk. The hard disk name is VDA, VDB, VDC. That's the story, guys. That is enough now for this one. Okay, so that is disk. Linux disk name. Of course, MBR, GPT kind of formats are there. So we'll see that one. Okay, disk management. Name of disk like this: /dev/SDA /dev/SDB. Okay, /dev/ things are like that. So meaning is this SCSI disk. Okay, first disk 1 means disk name is start with A. It is also SCSI disk 2. Names are like this. S represents SCSI or SCSI only. SCSI disk. H represent normal hard disk, meaning is IDE, PATA, SATA type of disk. Okay, in a storage we can able to discuss what is a disk and all. If you know, that is good. It is a virtual disk. Linux format, Linux virtualization formats. So Linux virtualization platforms, Linux virtualization platforms. /dev/SDA1 means partition 1. Disk 1, partition 1. Okay, so same thing, /dev/ sda2 disk 1 partition 2. So this is the disk. Okay, so this is like that, guys. So very simple way. Okay, so step by step we'll see how to disk management kind of stuff. The command we use is fdisk. Of course, gdisk is also there. Okay, gdisk is also there. Now we are not using bdisk. We are using fdisk only. We are using fdisk. So go to this man fdisk. Manipulate disk partition table. Manipulate disk partition table. Manipulate disk partition table. So fdisk -l will display what are the hard disks are there and what are their partitions. It will list what are the disks are located. So look at here, fdisk -l. Where is this? Yeah, it is showing. Okay, so because of it is GPT type of disk. So disk type is GPT disk. It is having some warning it is showing. So no problem. For GPT disk, you have to use gdisk. But no problem, fdisk also work with that one. GPT disk, it is showing 128 GB, but it is 120 GB only. The numbers are little different. Next. This is completely based on the sectors. Sector size, starting sector, ending sector, starting sector, ending sector, starting sector, ending sector, like that. Okay, so difference between starting sector and ending sector into 512. Okay, check it. So difference of starting and end sector number into 512, then you will get a size. You will get a size of partition. Because of each sector size. Sector size is 512 bytes. So keep it in that mind. So first of all, guys, so clearly I will tell simple practical. So then we'll go to the process again. So fdisk space -l. First of all, fdisk space -l. Okay, so it is showing there is a disk. This is the disk name. My hard disk name is /dev/ sda. It is 120 GB, and we are getting this is a GPT type of disk. GPT type of disk 128 partitions we can create it. This is the your partition table. This is your partition table. Compulsory root only we have to do it. This practicals with a root only or sudo here. Administration, right? So sudo here. So look at here like this. Only one hard disk, that's why it is showing like this is the partition table. This is my partition table. 120 GB SDA is my hard disk. Again, fdisk /dev/ sda. Fdisk as /dev/ sda. Now again it is showing something. M for help. Press M for help. This is the help kind of stuff. Okay, so you have to follow that help to do one by one, but I will tell what is that help kind of stuff also. So don't worry. This is help menu. Okay. After this, I will tell a sequence. Find out the sequence here. First of all, you press M for menu. M for help menu. So help menu. Then we got it, right? First of all, P. What is P? Print partition table. Print partition table. That is important. Next, V. Verify the partition table. So it will tell you how many sectors are available. Next, N. New partition creating. Like you want to create a new partition, N. Okay. Once you are created, there is a sequence you have to follow. That is, I will tell again. So once you are completed, again P. Again V. And P, after P, you have to go to T. Okay. Change partition is command. Okay, then L. List non-partition types. List non-partition types. The GPT type little different from normally. Non. So finally V. And finally D. W. So once everything is completed, write this. So this is one part. Okay. So this is a sequence, guys. Okay. This is a sequence. It is giving lot of things. Sequence is this one. D for delete. Another important one is D for delete. D for delete. Okay. So follow the sequence. First of all, P for partition table. This is my partition table. 5 partitions are created. 5 partitions are created. V, verify. 5 out of 128 partitions are created. Why? Because of it's a GPT. GPT 128 partitions we can able to create. MBR only 4 partitions we can able to create. No, it is like 3 primary, 1 extended. In extended we can create a logical partitions. Okay. Next, this is the number of sectors are free. So multiply this number free sectors into 512. So you'll get a total space. I'm not doing anything. I know there is a space is already available. Okay, because I take 128 GB, calculate this one. 80 plus 6, 86 GB used. Remaining free only, right? So almost like a 40 GB free. 40 GB or at least 34 GB is free. I know. 86 means 90, 120. So obviously 30 GB, 34 GB is free. Okay. Now I want to create a new one, N. See, no need to change anything, guys. Default is 6. 1 to 5 is completed. Default is 6. You put a 6 or no 6, no problem. Just enter. And don't touch the first sector. Just enter. Now I want to create a 2 GB disk drive, only 2 GB. You can create a 4 GB also, 10 GB also, no problem. I'm creating only 2 GB plus 2G. That's it. Completed. P, print the partition table. P, print the partition table. Okay, this is 2 GB is created. Next, T. You want to change type. You want to change the type, then you have to go to T. Which one? 6th one. You don't know what types are there. Press L. So this is the types. You can see these are all types only. So partition types. So take all the things and copy here. but we don't want all the things. We never want anything. Just we want a Linux swap, Linux file system 19, 20, and Linux LVM 31. Except that we don't require any other things. On another hand, guys, based on your Linux system, means CentOS, Red Hat, GPT type of partition, MBR type of partitions, then numbers are different. Okay, so like you go to the certain video or maybe some document, or maybe in your system it not showing these numbers. So compulsory what it is, compulsory check it. Based on your system only, you have to put this hex numbers. Okay, it is a partition types. Main important partition types are Linux swap, Linux file system, Linux LVM only. Remaining also important, but I am not telling anything. Guys, what I have done earlier. So here first I press the P, I check the partition table. Next I check the V. Next I check N. So N creating a new one. So it is showing a default 6. Okay. Also, okay. So P. After that one, before T. This is P. No. Before P, N. So it is this part. Okay. So default it is showing 6. You can choose anything. You can, meaning is depends upon your table. Depends upon your table. You can choose. So I'm not putting everything here. So this is also yeah, default enter. Don't type enter, just enter. First sector, don't do anything. Last sector, don't do anything. Okay, so give plus 2z or which one you want it, you can do it. Then partition is created. So I'm not telling because your system may different from my system. So n, so n is then partition number, enter, first sector enter, how much partition you want it, so enter, that's it. So next part is partition table. Next one is partition table. Then select T. Okay, and select which partition you want it. I want 20. I want 20. Then I choose 20 here for this time. Then P. It's a sequence, guys. It is. I choose 20. Then I put a P. So it is showing partition type is changed from Linux system to Linux system. Okay. So next time we do Linux swap. Now everything is completed. Go to V. Verify once it is little reduced. Finally W. Save and quit. Now it is telling your partition table is not updated in a kernel. Kernel having a old partition table. Okay. So what we are done. So P, better check V, finally W, save and quit. Now it is generating this error. Meaning is kernel is still using old table. Update the table or restart your PC. To reboot, command is reboot. Okay, reboot command is reboot. So I am using this command, or you can use this command also. I'm using this command. Partprobe. Partprobe. Okay, or you can use like a better is partprobe /dev/sda. Okay, just for you want to put any extra thing. So like this. SDA6, SDA7. So then Guys, this is the command part. This is completed. Next one, same terminal only. You have to give this command. Okay, update. Kernel to update partition table in kernel partprobe, or you can use part6. Next, guys, partition is created in Windows also. Once we create a partition, along with we are formatting it, right? So we are also formatting it. So what we are doing? It is we have to format partition file system ext4. Okay, you have to format, then only we can use it. mkfs.ext4 /dev/sda6, because my partition is 6th partition, so you have to make sure that one. So mkfs.ext4 /dev/sda6. Okay, format is completed. Once disk partition format is completed, okay, format is completed, you have to do mounting. So how to do mounting? First of all, create a directory. I put my directory name is 6 /. So better to create in a root or anywhere you can create, no problem. mkdir space / data. Okay, so mkdir / data6. So I'll create a data6 under root only, not in my current directory. So look at, I didn't create in my current directory. It is created under root directory. So it is data6 is created. So what is the kind of stuff in the data6? Nothing is there. Next, mounting. Mounting to things. So command is mount /dev/sda6 /data6. Mounting means connecting. Okay, /dev/sda6 data6. Mounting is done. Whether it is mounted or not, how to know? It is file is something is showing here, but here it is. Look at here, df space -h. You can see it is a mounting information. It is a mounting information. Okay, so how to check mounting? Df space -h. I'm removing all these things, but just for only one line. Okay, it shows this line. Please look at, so the page will be not required to fill everything. So it is. This is my partition 2 GB. This is free partition, and this is the where it is mounted. Tell me, guys. Okay, no problem. So I'm creating some files under /data6. Okay, so like a f6 1.5. So I'm creating a files in a data6. So look at here. So touch data, slash data6 slash f6 1.5. So ls slash data6. This is 61, 62, 63, 65 files are there. Okay. Next. Where the data is stored, where this data is stored in our partition only, where the data is stored inside this partition only, not in the directory. In this directory for only for accessing purpose, not for storing a data. Data stores actually in the this the file stores in the this partition only. How to know it? Just umount it. Unmount slash data6. Okay. Now check it. What is the content? Nothing is there. See, nothing is there. And check dev space -h. Where is the dev slash sda6? Sda6 is gone. The mount point is gone because of your unmounted it. Your unmounted it. So when you create a files, that time mounting is there. Data is created inside a partition. Data is created inside a partition. This is unmount command to remove the connection. Okay. What is this purpose? Unmount /dev slash sda6 to slash data6 unmount. Command is umount. And check the content of data6 is nothing. And check the mounting information. Next one is again I will mount. Again I will mount. See, mount /dev slash sda6 sdev data6. Now it is mounted. Check it. Mounting is there. Okay. ls slash data6 files are there. So you mount it, you can able to access the data. You unmount it, you can't able to access the data. Again check it. Mount it, so you will connecting, you can able to access the data of data in the this partition. You unmount it, can't able to access the data in the partition. Very simple. Next, you can mount this one to any directory only once, but now I connected to data6 directory. I can put it to any directory. Okay, I can put it to any other directory also. Data is same. Data stores in partition. Guys, understand up to here?
Yes, sir. Yes, sir.
Okay. It's a very look like a very long steps. So many steps are there, but last step also have to tell. Then it will be partitioning part will be completed. Then we will going to create another partition. That time at least try to tell. Okay. So this mounting is temporary. This mounting is temporary. Meaning is on next boot or restarted on next boot, it is unmounted. It is unmounted and not mount automatically. So this is one kind of stuff. So what we have to do it, specify the mount information in fstab. So whenever system boots mounts automatically. This is one. Okay. Now here we see how to do it. So go to vi space /etc/fstab. Okay, this is fstab, file system table. Here I have to specify /dev/sda6 is try to mount to /data6. Okay, which file system we are using? ext4 defaults 0 like this. So this is the line we have to add it to fstab. Now what I am going to do is ds space -h. There is a mount. So umount /data6. I am unmounting first. Okay, so make sure it is unmounted. vi space /etc/fstab. Okay. Go to down, small o, then insert this information. Okay, so how to do it? /dev/sda6. Press the tab where you want to mount. So data 6 and which file system? ext4 file system defaults 0 0. So once you are entered, save and quit. Save and quit. Now it is done. Look at here. Mount /data6. I did given a full also. Check it is mounted or not. It is mounted. Okay. You can unmount and restart or mount and restart. Anything. In a boot time also it will be mounted. Okay. So after this one, so first of all, the steps we have taken. Here it is. Umount data 6 df space -h df space -h. Verification is very important to understand. Now I've done this thing. Okay. Next. Mount /data6 only. That is enough. It will go to this file and verify where it is linked. It will mount automatically. Okay. So you can verify. Even though you restart your computer, automatically it will be mounted from here. But there is a problem will occur. Problem is the partition names like SDA, SDB, SDA1, SDA2 are logical based, not a physical or a stable, not unique. Not unique. It may change. May change. Possibilities there. So use unique. ID of disk partition. To give you get it blk ID, block ID. Command is block ID. blk ID /dev/sda6 6. We'll see blk id. So this is each partition their unique ID. So blk id /dev/sda6. This I will not. I will copy this one. So to see, okay, this is we require kind of stuff. Now copy this one in /etc/fstab. Put like this. So remove these quotations. Just remove these quotations. Okay, where you want to mount /data6. Okay, file system ext4 defaults 0 space 0. So like this we have to add it. So first of all df space -h. So umount, I am unmounting for testing purpose only. Umount /data6. Okay, now what I am trying to do is vi. So why I am telling, even though I want to stop for some time, there is two reasons are there. Insert only this unique ID, you have to copy the unique ID. Already I copied into my notepad, so I will take it from here. So no quotations, right? Yeah, like this. Now reduce the tab space is enough. Okay, and tab space is enough. If you want, you can give more one more tab space. Better give in a tab space like this, enough for an WQ. So this is how to add it. Unique ID. Now you can type, so like your mount /data6, whether it is mounted or not, find it. It is mounted. Now even you are rebooted 100 times also, you won't get a problem. Don't get a problem. Okay. So you mount first and verify this unmounted or not. Mounting information, df command for getting mounting information. H means human readable. Like G, M, K, like that you will get it. M, G, like this you will get it. Otherwise, only bytes, K, like that it is very difficult. Again, check it. So this is your total disk partitioning. Part number 1. So next one is, guys, we'll create one more partition. So one more partition. Again, totally we'll do all the parts. Second, we'll create a swap partition. So point is how much you learn, that is the secondary part. Important is what we learn, that we must know it. That's why we'll practice again. Currently take some 5 minutes break, relax. Okay. Understand guys, anything? 7 members are there.